like to invite Mr. Saugata. He is advisor, program management at International Center for Automotive Testing. He has also been part of R&D team at General Motors in his previous assignment.
Good evening, everyone. In the next 10 minutes, I'm going to talk on the use of polymers in automobiles and some focus on the body engineering area and advancements. These pictures are for those, if you have not seen the automobile, how it is manufactured, how complex it is. I mean, it's almost 4,000 to 5,000 components gets assembled in the body shop, paint shop, and assembly shop. And it is a very complex process. Now, with this complex moving equipment, what is the materials? We know from the historic time, the first automobile was made predominantly of the wood. Later on, use of the steel started. And till date, the steel is the major constituent of the automobile, almost 60 plus 66%, followed by the polymers, plastics, rubbers, other metals like manganese and glasses, and other materials. As we are going to focus and talk on the polymers, here is the typical use of the current different material in the various components of automobiles. It consists almost 10% of the weight, but the volume-wise, almost 50% of the volume of the material being used in automobiles are made of polymers. Now, question is why the polymers? In single line, we can say the versatility of the material. It is having a eraser type softness to rock hardness. It is having moldability, so you can give integrated forms of multiple components in single form, and advancement of the manufacturing technology, its resistance to corrosion, the transparency to the colored material, and the contribution to the safety. My previous speakers talked about the safety aspect, like say, we see the windshield. I mean, I don't know how many of us know that there is a thin layer of plastics in between the glass which is protecting us. Similarly, in the application of the seat belt, airbag, the application of polyester and the nylon fibers are tremendous. So polymer materials are available in the multiple forms. In all forms it is being used, whether it's plastics, whether it's a fiber, whether it's a paint, elastomer, foam, sealant, adhesive, and not last but not least, composite. Here are the different polymers, mainly the polypropylene, polyurethane, PVC. Similarly, there are 12 polymers which are very frequently used, and the first three constitute about the 66% of the material used in the polymer domain. Now, having said that, what are the factors which are driving the advancement of the polymers in automobile? We had a lot of talk on the recent advancements in the automobile industries, and basically it is the regulatory requirement which is driving to reduce the weight to have a better fuel economy. It is the safety factor which is driving the innovation of the materials, and also the styling and the design, better aerodynamic shape, better fuel economy, and of course the manufacturing technologies like 3D printing or the resin transfer molding advancement. Those are contributing for the use of polymers in automobiles. So here is an interesting fact. In one side we are saying that reduce the weight, and other side, the customer demands of the comfort, the safety, all are increasing, and because of that the designers are complaining to increase the stiffness, increase the power of the engine, and increase the size of the vehicle. To give an example, here is the old Alto versus new new Santro and old Santro. The new Santro is almost 100 kg plus weight as compared to its previous versions. And that is the fact in most of the platforms across the globe for all the OEs. The generation after generation, the vehicles are becoming better, larger, and heavier. And at the same time, then we have the challenge, we have to reduce the weight. So what's the solution? So this is a spectrum of the material available, where it shows that specific strength is nothing but the strength versus density, strength by density. So if you see, other than the metal, we have a vast, amount of the material advancement, mainly because of the composite material, where due to the lower density of the material, the high specific strength materials are available to the designers now. Now, how this composite is blessed? It is blessed to have due to the innovation of this carbon fiber, which is having tremendous strength, almost 10 times higher specific strength than steel and almost double relative stiffness. And coupled with its high stiffness, corrosion resistance, heat resistance, and the electrical conductivity. So this is making the advancement in the composite area, which is very much talked globally. So other than that, its high strength to oil ratio and the fast processability also making it usable. Here are the examples, some of the high-end cars where the plastic composite reinforced with the carbon fiber being used. Mostly these are costly or the sports cars where the body and the other area, the plastic carbon fiber composite is being used. This is a vehicle displayed by Unity in last year Auto Expo. Those who have visited Auto Expo possibly have seen this electrical car, which we know that this is going to be launched in India very soon, probably next year at the announced in Auto Expo. And to reduce the weight, here the entire body is made with the carbon fiber-based composite. So in the previous slide, which I showed mostly the high-end cars, whereas here it is affordable car, we believe. Now, here are the other examples where the carbon fiber composites is being used, like Volvo, they have tried to use in the body skin and integrated the battery design. So this is an experimental vehicle. Now, here are the advancement of the technology. Like we have the PCM, where the materials are impregnated with the polymers or resin materials, preheated, given shape, and then finally given the compression and curing. Similarly, in the advanced resin transfer molding, the composite fibers are given pre-shape, then we transfer the material, and there is a curing. So here the typical cycle time is range from 3 to 5 minutes depending on the polymer composition. So this is suitable for where you have a, low production rate. It can sustain a single mold, possibly 50,000 volume per annum kind of things. Whereas if we like to have a more volume production, this is another technology available, which is intelligent molding line. So in this line, the beauty is the plastic material and the other ingredients, as well as the fibers, they're getting mixed in the same process, in online mixing, and the molding is happening. So here, along with the glass or carbon fiber, we can use all the thermoplastic materials like whether polyamide, PP, and here are the examples, some of the molded material out of this technology. Okay. So the bottom one, the integrated font module, where you can see the consolidation of the multiple parts. So the moment we are able to consolidate multiple parts, indirectly that is giving the saving of my assembly time and can help to reduce the cost. So in summary, these are the three things which is going to drive the Indian automobile industries, we believe. That BS6, which is going to be implemented from the next year, April 2020, then emergence of the electrical vehicle, and the end of life of the vehicle, ELV. ELV is not still a regulatory requirement, but that is very important considering the recyclability of the material and the environment aspect. There is a AIS 129, which has been released by ARI. However, that is yet to be translate as a law in the country. So in nutshell, going forward, polymer is a very important contributor to the automobile industries, and going forward, it is going to be helping the innovation to greater extent. And to do that, we need more collaborative approach between the OEs, the designers, between the academia, and the system or component manufacturers. So in turn, this will support the Make in India mission. And last but not least, we say that being a responsible corporate citizen or person, we need to take care of the recyclability of the material. So I know, we do take care, but some of the material which are prohibited, which are not supposed to be used, so designers need to take care from that. And if we can engrave the material code in the mold, so that will help the segregation of the material and recyclability at the end of the vehicle life. With that, I'd like to stop and like to thank all of you for your patience hearing me.
Thank you, Mr. Pa.